guys, this is Headlines. The news that Microsoft is bringing ChatGPT technology to Office Suite has dropped a bomb to the entire tech world and has been all over my feed since last week. Microsoft called the feature an AI Copilot, which would help edit, summarize, create, and compare documents. To my surprise, it's even able to generate data tables and charts as well as PowerPoint. My feeling for ChatGPT is nowhere near as the same as it was months ago. I mean, now everything is almost concrete and tangible. A long-awaited, surreal but nice solution to set us free from tedious work. Or maybe I'd say set us free from our jobs. I guess ChatGPT somehow has entered the uncanny valley, and that's the reason why people got this uneasy feeling about it. Today I want to recommend you an article about ChatGPT written by Ted Chiang, an internationally renowned science fiction writer, whose short story, The Story of Your Life, was the basis of the film Arrival in 2016. The article was first published on New Yorker in February this year, but at that time, I didn't take it too serious. However, the ideas of the article stand out as the technology becomes increasingly powerful and incredibly influential. Ted Chiang offered some philosophical thinking and humanistic care in this article as well as he did in his novels. It's not half as difficult as some of the articles in Economist, except for some terms in computer, but I want you to pay more attention to the logic and ideas behind the language, and how the writer pushed forward layer by layer to illuminate the concept. Isn't it wonderful things that we communicate with the great mind? By reading this article, you get a gist of Ted Chiang's language style, as well as extraordinary perspective on ChatGPT. And it's a relatively long article, and I'll split it into 3 parts. We'll go through about 1,000 English words each day in this week. So take a deep breath. Let's go. In 2013, workers at the German construction company noticed something odd about their Xerox photocopier. When they made a copy of the floor plan of a house, the copy differed from the original in a subtle but significant way. In the original floor plan, each of the house's 3 rooms were accompanied by a rectangle specifying its area. However, in the photocopy, all 3 rooms were labeled as being the same square meters in size. The company contacted the computer scientist to investigate this seemingly inconceivable result. They needed a computer science because the modern Xerox photocopier doesn't use the physical xerographic process popularized in the 1960s. Instead, it scans the document digitally and then prints the resulting image file. Combine that with the fact that virtually every digital image file is compressed to save space, and a solution to the mystery begins to suggest itself. 房间大小本来是3个不同的数字，但是在复印之后却变成了一样的3个数字。原因是复印机不是传统的物理静电复印技术，而是数码扫描之后再打印，结合数码图像文件被压缩以节约空间的这个事实，这个神秘事件的原因即将浮出水面。Writers will be writers, right? Compressing the file requires 2 steps. First, the encoding, during which the file is converted into a more compact format, and then the decoding, whereby the process is reversed. If the stored file is identical to the original, then the compression process is described as lossless. No information has been discarded. By contrast, if the restored file is only an approximation of the original, the compression is described as lossy. Some information has been discarded and is now unrecoverable. Lossless compression was typically used for text files and computer programs because those are domains in which even a single incorrect character has the potential to be disastrous. Lossy compression is often used for photos, audios, and video in situations in which absolute accuracy isn't essential. We don't notice if a picture, song, or movie isn't perfectly reproduced. The loss infidelity becomes more susceptible only as the files are squeezed very tightly. In those cases, we notice what are known as compression artifacts, the fuzziness of the smallest JPEG or MPEG images, or the teeny sound of low bitrate MP3s. This paragraph is easy to understand, right? Don't you think the process of encoding and decoding is kind of like dehydrated and rehydrated in 3-body problem? 如果压缩后的文件和原文件是一样的，那说明它是无损的 lossless。那如果不是这样的话呢，它就是一个有损的 lossy， 且有损的部分是不能够恢复的。 通常在文字文件或者计算机编程等这些容错率比较低的领域里面，使用的是无损的压缩，因为一旦有损呢，它的后果可能会很严重。但是像视频、图像、音频，只有在它被压缩的非常严重的时候 squeeze tightly， 你才有可能意识到它和原版之间的差别。比如压缩的很糊的 JPEG 图片，或者是声音不够浑厚发尖的 MP3 格式。Xerox photocopiers use a lossy compression format designed for use with black and white images. It turned out that the photocopier had judged the labels specifying the area of rooms to be similar enough that it needed to store only one of them, and it reused that one for all 3 rooms when printing the floor plan. 复印机采用的是有损压缩的格式，他认为3个数字是一样的，所以就存了一个，以至于后面打印出来的数字都出错了。The fact that Xerox photocopiers use a lossy compression format instead of a lossless one isn't in itself a problem. The problem is that the photocopiers were degrading the image in a subtle way, in which the compression artifacts weren't immediately recognizable. If the photocopiers simply produced blurry printouts, everyone would know that they weren't accurate reproductions of the originals. What led to problems was the fact that the photocopier was producing numbers that were readable but incorrect. It made the copies seem accurate, but they weren't. 复印机使用有损压缩不是问题的，问题在于是 the photocopiers were degrading the image in a subtle way, 以一种细微的不让人立即察觉的方式把图像的质量降级了。如果复印机打印出来的是模糊的图像，人们很快就能意识到这跟原版不一样。但是呢，复印机产生的是一个可读的、清楚的，但是不正确的复印件。Guess what? That could be conceivable enough to cheat humans. I think that this incident with the photocopier is worth bearing in mind today as we consider OpenAI's ChatGPT and other similar programs, which AI researchers call large language models. The resemblance between a photocopier and a large language model may not be immediately apparent, but consider the following scenario. You plan to create a compressed copy of all the tests on the web so that you can store it in your private server. Your private server has only 1% of the space needed. You can't use the lossless compression algorithm if you want everything to fit. Because you have virtually unlimited computational power to throw at this task, your algorithm can identify extraordinary nuanced statistical regularities, and this allows you to achieve the desired compression ratio of 100 to 1. 我们假设你要把全网的文字都存下来，但是你只有1%期容量大小的空间。这里提供给你一个超能力，就是你可以用任意高级的算法来压缩数据，最终达到这个目标。You've got all the information on the web stored on your server. The only catch is that because the test has been so highly compressed, you can look for information by searching for exact quote. You never get exact match because the words aren't what's being stored. To solve this problem, you create an interface to accept queries in the form of questions and response with answers that convey the gist of what you have on your servers. That is a core concept of today's episode because the text has been squeezed tightly. It is no longer the original one that you could search word by word in hope of mapping and restoring what exactly it was before. Just as you were able to search a query on Google, where you could find the contents contain your queries. 在把全网的文字都压缩之后，如果你想用一个具体的词或者句子去找对应的结果，是根本找不到的，因为整个互联网的文本在经过压缩以后呢，已经面目全非了。你只能通过一个 interface， 一个交互的接口，通过提问题返回答案的这种形式来找到存储在服务器上数据的概要。What I've described sounds a lot like ChatGPT or most any other large language model. Think of ChatGPT as a blurry JPEG of all the tests on the web. It retains much of the information on the web in the same way that a JPEG retains much of the information of a high-resolution image. But if you are looking for an exact sequence of bits, you won't find it. All you ever get is approximation, but because the approximation is presented in the form of grammatical tests, which ChatGPT excels at creating, it's usually acceptable. You are still looking at a blurry JPEG, but the blurriness occurs in a way that doesn't make the picture as a whole look less sharp. ChatGPT 以语言的方式提供给了你一个近似的答案 approximation 近似值，因为呢它是以人类语言的方式出现在你面前的，所以你会觉得非常可接受。但是实际上呢，你看到的还是一张模糊的被压缩的 JPEG 图片，只不过它的模糊方式不会让整个图像看起来不清晰。This analogy to lossy compression is not just a way to understand ChatGPT's facility at repackaging information found on the web by using different words. It's also a way to understand the hallucinations or nonsensical answers to factual questions, to which large language models such as ChatGPT are all too prone. These hallucinations are compression artifacts, but they are plausible enough that identifying them requires comparing them against the originals, which in this case means either the web or our own knowledge of the world. When we think about them this way, such hallucinations are anything but surprising. While you may be baffled by this clause, to which large language models such as ChatGPT are all too prone. Well, here ChatGPT is too prone to what? Let's rewrite the sentence. The analogy is also a way to understand the hallucinations that ChatGPT is prone to creating. 实际上 ChatGPT 也是非常的擅长于以一种有损的方式去压缩语言，创造这种 hallucination 或者是 nonsensical answers。所以从这个角度上来看的话， ChatGPT 所提供的这些答案，这些 hallucinations are anything but surprising， 一点都不让人觉得惊奇。This analogy makes even more sense when we remember that a common technique used by lossy compression algorithms is interpolation. That is, estimating what's missing by looking at what's on either side of the gap. When an image program is displaying a photo that has to reconstruct the pixel that was lost during compression process, it looks at the nearby pixels and calculates the average. This is what ChatGPT does when it's prompted to describe, say, losing a sock in the dryer using the style of the Declaration of Independence. It is taking 2 points in lexical and generating the text that would occupy the location between them. ChatGPT is so good at form the interpolation that people find it entertaining. They've discovered a blur tool for paragraphs instead of photos and are having a blast playing with it.And interpolation 翻译成差值，也就是说两个像素或者两个针之间，然后用一些算法把它们拼接起来，让它们看起来是连成一体的。举个例子呢，就是用独立宣言的风格去描述在烘干机里丢了一只袜子。那实际上就是 take 2 points in lexical space， 在词汇的空间里面找到两个点，然后通过算法生成这两个点之间的内容，把它们填充起来。ChatGPT 非常善于生成填补语言的差值，它好像给人们提供了一种基于文字段落的模糊工具，让人们玩得不亦乐乎。第一部分实际上就是做了一个对于图像压缩和文字压缩的类比，它们之间的共同点都是没有办法再去追溯到最原始、细节最丰富的那个文件上，所以只能采取一些 interpolation algorithm 差值的算法，把几个点之间的空缺填补起来。You know what? That's 1/3 of the article. Come on, we can do it in the next few days. Stay tuned this week and see you tomorrow.